Hey guys, today we're going to go ahead and look at graphing polynomial functions. And polynomials are anything that have to the power. Right here you can see. And the easiest way to start it, make sure you write them in descending order. We're going to start by looking at the end behavior. Okay? And the end behavior of this graph, if you remember, because it is even, that means both ends are going to go up. Both ends up. If you forget, just draw the graph of a quadratic. Remember, this is x squared. It's even and it's positive. If it was a negative, you would have it going downward. So this would be negative x squared. It's still even, but it's negative, so we just flip it down. Now the same thing goes with x cubed. You should know that this is the general graph of x cubed. Now what happens to negative x cubed? Well, then it would just flip down. Okay, and you can see here with x cubed be down on the right and it goes up on the left. I'm sorry, down on the left and up on the right. The next thing we're going to look at is the X-Intercept. Now you guys know how to find the X-Intercept. Something new we're going to introduce is called multiplicity. And multiplicity has to do with the factors. So when we take a polynomial, we are going to factor it, and then we're going to look at the factored form. If the exponent is odd, the graph is going to cross at that X-intercept. If the exponent is even, the graph is going to bounce at that X-intercept. Okay, now from there we're going to go look at the Y-intercept. We're going to be set x equal to 0. And then we're also going to use test points. And this I just put it just for review, max number of zeros. The max number of zeros, if you recall, is just looking at the exponent. So the max number of zeros is 4. Now what about the turning points or concavity? This is where the graph is going to be changing shape. It's whatever the zeros are, the max number of zeros, subtracted by 1. So 4 minus 1 is 3. So this graph, this polynomial, has at most 3 turning points. Okay, so let's go ahead and take a look at what this guy is going to look like. Okay, so we know that the end behavior of this graph is even, so both are going to go up. So this end on the right and this end on the left, somehow this is going to go up. Okay, alright, the next thing we're going to talk about X-Intercept. Okay, so how do we find the X-Intercept? Simple, set y equal to 0. Now, in Algebra 2 and Pre-Cal, f of x, that's our y, so we're going to set that equal to 0. And we have x to the 4th minus 2x cubed minus 3x squared. Now the first rule in factoring is, can we factor out anything that's common to the whole three terms? And the answer is yes. We can take out a x squared. Okay, what's that going to leave us with? Well, if you notice, it's going to leave us with x squared in the front minus, this is 2x cubed, so we need a 2x. X squared times 2x is 2x cubed minus a 3, and that's all we need because x squared times 3 is 3x squared. Now this guy here, we can continue to factor him. Okay, x times x gives us x squared. Factors of negative 3 to give us negative 2. Well, we need a positive 1 and we need a negative 3. 1 minus 3 is negative 2. 1 times negative 3 is negative 3. Okay, now our factors are, or x-intercepts are 0, negative 1, and positive 3. Now this is where the multiplicity comes in. This is to the power of 1 to the power of 1. Now what about x squared? Now that guy, we can write him as x minus 0 to the power of 2. Okay, so what we're going to say is this guy at x squared, or at x equals 0, is even multiplicity. Okay, and what about x plus 1 and x minus 3? X plus 1 is to the 1, x plus x minus 3 is to the 1. This is odd multiplicity. So what's going to happen? And what I did is I came up with a little acronym, Kobe. It's going to cross when it's odd, it's going to bounce when it's even. So if I come over here and look at my graph, let's see here, 1, 2, 3, 1, 2, negative 3. Okay, let's go ahead and draw this out. X equals 0. It's right there. Okay, now what's going to happen here? You notice that it's even. Okay, what's going to happen when it's even? It's going to bounce. So the graph somehow is going to come here, is going to touch, and it's going to bounce off. Okay, that's all I know. Now, what about here at -1 and +3? You see they're odd. Okay, at -1, it's right here, it's going to cross. And I'm thinking something like that. Right through that intercept. Same thing at x minus 3. X minus 3 with the zero product property, we get 3. It's going to cross the x-axis. Okay. Now we have a better idea of what this graph is going to look like. So we got our x-intercept, we got our multiplicity. Now we need our y-intercept. Now for our y-intercept, we need to go ahead and set x equal to 0. Okay, so let's go ahead and take this guy f of x. We'll put f of 0, 0 to the 4th minus 2 times 0 cubed minus 3 times 0 squared. And when you do the math, you get 0. 0 times 0 times 0 is 0. And we already have it. Okay? Now, there's other things we talk about, what's called Descartes' rule of signs, but we can talk about that later. Now, we know in general what this graph is going to look like. Now the last thing we need is test points. So now let's see here. About -1. I don't know what happens at -1. And I know it's going to go down, but I don't know how far down. So 1, 2, 3, 4. Function is at +1. 1 to the 4th minus 2 times 1 cubed minus 3 times 1 squared. F of 1. That's going to give you 1. Now here, first do the exponent. 1 times 1 cubed is 1 times 2 is 2, or minus 2. Minus 1 squared is 1, minus 3. So f of 1 is 1 minus 2 is -1. -1 minus 3, -4. So this would be -4 somewhere right here. Well, what about at 2? Does it go up or does it continue going down? I don't know, so let's go ahead and try it out. F of 2. 2 to the 4th minus 2 cubed minus 3, 2 squared. Now 2 to the 4th is 16. 2 cubed is 8. That'll be 16 minus 3 times 4 would be 12. This gives you a 0. So the value of the function at 2 is -12. So this guy goes way down here somewhere. Okay? And that's okay. Now I have a better idea now what this graph looks like. It's going to come through this point. It's going to go way down here somewhere. I don't know. It's going to eventually come up. It's going to come through and touch right here at 3. It's going to come up here. And this guy here looks like it's going to come here. And actually, he's going to go up here. And you can check it by graphing it in your calculator.